Okay, guys, our next unit in trig and pre-calc is going to be conics. We're going to be doing this for the next month and a half, right till mid-May, and then we'll finish up the year with limits. All right, so let's start with the big picture. This is in chapter 11 in your textbooks, by the way. Okay, so conic sections. Okay, before we actually get into how to create the conics and their connections to what we've done already, I just want to get into what an actual conic section is, because I think that that's important to understand before we actually go and do anything with it, right? So here's what we're going to start with, okay? So if you can visualize for yourself, oh come on, please focus. Let me try this, see if that focuses it better. Okay, yeah, sometimes the light right on it, right, doesn't. Okay, there we go. Okay, conic section. So, here we go. Start with a cone on top of a cone. Okay, hopefully you can visualize this. Now, I don't have my conic section models. They're in the school, so we're going to have to visualize. So these are two cones stacked on top of each other. Okay, this is a double napped cone. Okay, where they only intersect at their vertex. Okay, so what conic sections are? Conic sections are just cross sections of cones. Of a double napped cone. Okay, so you've done conic sections before, they just might not have been called that. So if you take your slice, right, if you take your paper or your saw and you cut, and let's say you cut and you're perpendicular to the horizontal axis that goes up and down here. So the horizontal axis goes up and down. If you cut this way, what would you get as a shape? Well, you see it right here. You get a circle. Okay, so one of the conic sections, right, type 1, the most common one that you've done, is a circle. Okay, it's created by slicing a cone perpendicular to the horizontal axis, or to the height. It's called the horizontal to the vertical axis. Okay. For ourselves, okay. Hopefully you remember from years past, right, that when you have your circle, okay, your equation for it, x minus h squared plus y minus k squared equals r squared. Okay, that's basically just the Pythagorean theorem, by the way, right? As we did it, h and k. So here's your point. Okay, for any point, your horizontal distance is x minus h. Right, your vertical distance is y minus k, and you do your Pythagorean theorem, and that gives you the equation for a circle. So circles are just the Pythagorean theorem. Okay, in case you didn't realize that from before. Okay, now let's talk about type 2 of the conics. Right, type 2. Right. Okay, let's say we take our cross section, and instead of slicing it perpendicular, right, to the vertical axis, let's say that it's parallel to the vertical axis. Okay, so it's just like this. Okay, so what would actually happen? So what we have to think about is that if you're going to slice like this, right, and I'm going to put little marks on it like this, okay, you can see, right, what we get. And now, okay, you're going to have to kind of turn this in your head a little bit. I don't have the diagrams with me, right? So if you think about it, right, in the back and the front, there's going to be slices coming down. It's going to be kind of like this. Okay. Right, this is the axis. Right, we're going to get two parabolas on top of each other. Okay, so, and that's called a hyperbola. Right, and it's it's created by the cross section that is parallel to the vertical axis. Okay, so what would it look like? It would look something like this. Okay. If our cones were turned this way, and then okay, we'd have a horizontal axis, but I'm just saying vertical axis as the height instead of the height. But if this was sideways, then this would go like this. It would go like that, and that's okay. I mean, you can have that if these two are, when they're stacked, they're put side to side, right? If it's drawn like this, right, then that would happen. Okay. Right, so that's what our hyperbola looks like, and we'll get to the equation of that later on. Right, I just gave the circles one because I figured, hey, we know that circles one. Okay, so there's our hyperbola, right, by slicing this way. Type 2. Okay, now if this slice were to go through the vertex, okay, we would get a degenerate conic. And actually, you can see what a degenerate conic is, right? This right here is our degenerate conic. If it was sliced, our paper is slicing that cone, right, along, and it passed through the vertex. You can see it's two different lines, okay? So, right, let's write down. So, if the cross section, or this, let's say this cross section, intersects the vertex, the degenerate conic, and this is a set of intersecting lines. Okay, and that would look something like this. Okay. That would be the cross section. If you were to slice it and it passes through that vertex, there would be the vertex, and you see two lines there. Okay. This term degenerate conic is the name, right here. That's something you definitely want to highlight for yourself. Let's see that highlighter here. Yes, I do. Okay. This is a general term we use. It's not just for this one, but that's for any conic. Degenerate conic. That's any conic that passes through the vertex here itself. Okay. So there's type 2, right? That's our hyperbola. There's the degenerate. For what it's worth, right, if we had a degenerate conic for the circle, remember the circle was like this, if it were to pass through the vertex, it would just be the only point. So for this one, the degenerate version is a point. And if you think about it, this makes sense. As the slices get closer and closer to the vertex, these circles get smaller and smaller until they eventually approach being just a point. So far, hopefully that makes sense to you. Okay, let's think about type 3. So we've thought about parallel to the vertex, parallel to this axis, and perpendicular to the axis, right, for ourselves. So what if it is parallel to one of these sides, right? If it's parallel to one of the sides, right, that means you're going to slice kind of like right here. Okay, so this is type 3, and it would kind of go in this direction. Let me use the pink for it. Okay, that's what the slice would be. Notice that since it's parallel, it's only going to intersect one of the conics, not both of the conics. Right? And if we look at it, what it's going to do is going to cut that in half, and you would trace two of the sides, and you would get for yourself the parabola. So the parabola is another type of conic section that we're going to have, and this one is a cross section parallel to one edge of the conic, or edge of the cones. Okay? All right, we'll get our parabola. You've looked at parabolas extensively before, and we'll get into more detail with them about all the important stuff like the foci, the directrix, the endpoints of the latus rectum, all the fun stuff that goes along with it. Right? The vertex, that's a pretty common one. Okay. If we look at this and we think about what would happen if it's degenerate. Right? If this was degenerate, slides down. Degenerate, then it would be right on that edge. And what would you have? You'd have 1 point. I'm sorry, you just have a line there. Okay? So the degenerate version is a line. Okay. And just like we talked about with hyperbolas, they can be sideways, right? So if the cone, instead of being top to bottom or left to right, then you'd have that sideways, right? Or if it was going off of, like if you were parallel this side, then it would be going the other direction. So there's lots of different options there, right, for how that can be drawn. Okay. Last one for ourselves. Okay. Well, what if it's not parallel or perpendicular to anything, and you just were to take it, and I'm going to use the edge of the paper here instead of having it like this, right? What if it was kind of askew here to all the axes? Okay, you can see it only is going to intersect one conic if we were to do something like, I'm sorry, one of the cones if we're going to do that, either the top or the bottom. Okay, for ourselves, but you can see that it hits the ends, like unlike this the parabola, which kind of just remember these cones. I'm sorry, maybe it wasn't clear. These cones go on forever and ever and ever and ever and ever. Right? They're unlimited in their height. Right? That's why it's going to go up. Right? If we were to go this direction, we'd have a finite end to it. But since we're at a slanted angle here, right? Instead of it being a circle, it would become an ellipse for ourselves. So if we had something like this, okay, it would kind of loop out. And you could see that it really gets extended there, right? It goes further in one direction than the other ones, right? Because of that slantedness to it, okay? And I'm sorry that I can't really show you the diagrams to justify that, right? But if your parents have a cone lying around and they have a saw, have them cut it for you and you can look at it, right? That's what I would have shown you. So anyway, okay, so we have that ellipse as our last one, okay, and it's a cross section is askew or oblique to the vertical axis. It's intersecting, but it's not perpendicular, whatever you want to call it. All right, so you're going to have something that looks like this, and depending on how you were to cut it, which way that cross section goes, it could also be looking like this. Right? Okay, it is not an oval. Oval a little different. It's oval-like in shape, but ellipse does have a specific set of points for ourselves. Okay, if we were to think about this in the cross section that was degenerate, you'd see it pass through the vertex. So the vertex, right? This is a degenerate. Degenerate is also a point. Okay, for ourselves. Okay. So as we're looking at this, right, it's kind of circular in shape, but instead of having a consistent radius, it really changes as you go through it because it's going to go further in this direction than this direction, and that's going to make our equation look a little different. So hopefully, right, you can see those are the four types, right? There's no exact problems on this for homework, but it's just something that you should read through so you understand where all the conics come from that I expect you to know for the test we'll have on this, right? If I said describe how to create each cross section, you should know how to create it. You should also know what the degenerate is for each one, what it's going to look like. Right?